Today we started with a review of special angles from grade 7. So we reminded ourselves that supplementary angles are two angles whose sum is 180. Complementary angles are two angles whose sum is 90. And then we looked at vertical angles and linear pairs. So vertical angles are created by intersecting lines, and they're the opposite angles. Maybe you remember from last year, vertical angles are always congruent. So for example, here we have these two angles. They are opposite of each other, they're across from each other, and they are also congruent. So in the picture with the angles numbered, 2 and 3 would be vertical angles. And we also have another pair of vertical angles, angle 1 and angle 4. So angle 1, whatever its measure is, angle 4 would have to be exactly the same. Whatever angle 2 is, angle 3's measure has to be exactly the same. We also have a linear pair. Linear pair, two adjacent angles, so they share a side, they share a vertex, and they create a line. Remember, if they create a line, they would have to add up to be 180, so they are supplementary. So in that same picture, if I were to look at the pink line, if I were going to look at the top side of that, I see angles 1 and 2 create that straight line. So angle 1 and angle 2 form a linear pair. If I were going to look on the bottom of that line, I see angle 3 and angle 4 would also create that straight line. So angle 3 and angle 4 are a linear pair, which also means they're supplementary. So 3 and 4 have to add up to be 180. I could also look at the other line. So if I were visualizing that, on the left side, I see angle 1 and angle 3 make up a straight line or a straight angle. And on the other side of that, we also have angle 2 and angle 4 that create a linear pair. So those were review angles from grade 7. So for our grade 8 standard, we're going to look at special angle pairs formed when we have two lines cut by a transversal. So in the picture at the top, the red line is a transversal. It intersects line A at the purple point. It intersects line B at the green point. So since the red line intersects line A and line B in different points, we would call it a transversal. A transversal is a line that intersects two or more lines at different points. When that happens, we have different angles that we could consider. So we have interior angles. Interior angles are angles inside or between the two lines. So if we were to trace the two lines and look at what's in between them, we see angles 3, 4, 5, and angle 6. So then exterior angles would be on the outside of the two lines. And if we look back at that picture, we see angles 1, 2, 7, and 8. And then another term that we are going to use a lot when we're identifying angle pairs would be alternate, and that just means they're on opposite sides of the transversal. For example, 1 is on the left side of that transversal, whereas 8 is on the right side of the transversal. So we have 4 kinds of special angle pairs formed when two lines are cut by a transversal. And the first of those 4 is corresponding angles. And corresponding angles are in the same position. And we just need to make sure that we're choosing one from each cluster of angles. And what I mean by cluster is at this top intersection point, we have a cluster of 4 angles. At the bottom intersection point, we have another cluster of 4 angles. So if I were looking at the top cluster of angles and focusing in on angle 1, if you were to describe the position of angle 1, you might say it's on the top left. And then to find its corresponding angle, we would look in the bottom cluster and say, okay, what's in the top left? And we see that that's angle 5. So 1 and 5 are corresponding angles. In the same way that 2 and 6 would have to be corresponding angles because they're both in the top right of their cluster. We would also have angles 3 and 7 that are corresponding angles. They're bottom left. And our last pair of corresponding angles would be angle 4 and angle 8. The second type of special angle pairs are alternate interior angles. So we see interior and we think they're on the inside of the two lines. We see alternate, and that means they're going to be on the opposite sides of the transversal. And we're choosing one from each cluster. So one from the top set of angles, one from the bottom set of angles. So inside of the two lines, that means we're only looking at angles 3, 4, and 5, and 6. And then from the top cluster, if I were to choose angle 3, then from the bottom cluster, I need to choose the angle that is on the opposite side of the transversal. So 3 we could think about as being on the left side. So I need this other angle to be on the right side. And so in the bottom cluster, that would be angle 6. So 3 and 6 are alternate interior angles. In the same way, 4 from the top cluster, it's the interior angle. It's on the right side of the transversal. So from the bottom set, angle 5 is on the left side of the transversal. So angle 4 and angle 5 are alternate interior angles. The next special angle pair are alternate exterior angles. So we see exterior and we're thinking they're on the outside of the two lines. Alternate tells us they're on opposite sides of the transversal. And again, one from each cluster. So outside of the two lines, that means we're not talking about 3, 4, 5, and 6. We're talking about 1 and 2, 7 and 8. Opposite sides of the transversal. So if I'm looking at angle 1, angle 1's on the left side of that transversal. I need an angle from the bottom that's on the right side. It has to be exterior, so that would make it angle 8. So angle 1 and angle 8 are alternate exterior angles. In the same way, 2 and 7 would be alternate exterior angles as well. And our last special angle pair are same side interior angles. They're also known as consecutive interior angles. So you need to know both of those names. You're going to see both of those names. You need to be able to recognize them. I see interior on both, so they are on the inside of the two lines. And I do have a preference. I like same side interior angles because that tells us they are on the same side of the transversal. So again, we're talking about interior angles, not 1, 2, not 7 and 8. So if I'm looking at angle 3, I need an angle from the bottom cluster of angles that is on the same side of the transversal, and that would be angle 5. So angle 3 and angle 5 are same side interior angles, and 4 and 6 are both on the inside of the lines. They're on the same side of the transversal, so they would be same side interior angles as well. Again, we could also call those consecutive interior angles.